All right, guys. So in the previous video, I did just a quick bridging between chapter 12 and chapter 13, or rather between kinematics and kinetics. Basically just showing the basic relationship between them, that kinematics, we're only looking at the motion, and kinetics, we're looking at what causes the motion. And we need to understand how these two link together. And I showed essentially that the basic idea is that kinematics is based on Newton's second law, F equals ma. And with regards to problems in kinetics rather, we often are given force information and we are required to calculate kinematic information. Or it's possible we could be given kinematic information and we are required to calculate force information, or we can just be going back and forth. Okay, so chapter 13, kinetics of a particle. Please remember what a particle is. And in chapter 13, we're looking at force and acceleration. Okay, force and acceleration. And just as I mentioned in the previous video, and now, it's really based on Newton's second law. Okay, this is the basis, Newton's second law. Okay, it just says here, kinetics is a branch of dynamics that deals with the relationship between the change in motion of a body and the forces that cause this change. Okay, so there's the change in motion, right? That's what we're looking for. Or that's not necessarily what you're looking for, but that is the change in motion side. And there we have the forces that cause the change. Okay? And it says here, the basis for kinetics is, what is it? It's Newton's second law. Newton's second law, which states that when an unbalanced, guys, what's an unbalanced force? Unbalanced force. Right, we know if there's a body there, and I have, say, got two forces there. Unbalanced force is just simply if we look at all the forces, we analyze the forces, and we add them up, then they cancel each other out. Okay? Sorry, a balanced force means they cancel each other out. An unbalanced force means they do not cancel each other out. So unbalanced means not cancel each other out. Okay? So take note of what is an unbalanced force. And when we have this unbalanced force, the particle will accelerate. It will accelerate, okay? And it's very important that it'll accelerate in the direction of the force. Okay? So let's just take a look at this next one here. So 13.2 is the equation of motion. So the equation of motion is given by this here. Sum of the forces equals mass times acceleration. I hope you guys can see this. Maybe I can just try to zoom in a little bit. Okay? So if we ask you, what is the equation of motion? Immediately you know it's this. Okay? It's essentially Newton's second law, but what we're looking at here is not just a single force, but the sum of the forces. So there's multiple forces acting on a body or a particle, and if the sum of these forces are unbalanced, then it's going to cause an acceleration. Okay, so that's why this chapter is called Force and Acceleration. Kinetics of a particle, force and acceleration. Right? It's because we're looking at Newton's law, and we're looking at how forces cause a particle with mass m to accelerate. Okay, so just quickly, there's a particle, there's a couple of forces. The forces are unbalanced, and as you can see in this next one, these two forces, if you do a vector addition, okay, vector addition of the free body diagram of the forces, you're going to get a resultant force Fr there that's in that direction, and the acceleration must always be in the direction of the resultant force. Okay? So there we have that. Then finally, just 2 quick points. We can often look at problems with a single particle. Okay? A single particle. For example, there's a single particle, and we've got 2 forces acting on it. Let me just bring the textbook here, and I can show you some examples. So you've probably done this one in class, example 13.1. But there's a single particle. All right? Let me just get that. 13.2, you've got a single particle. Okay? 13.4, again, you've got like a single particle. All right? A single particle. And you're analyzing a single particle. Okay? But it's also important that we understand the next one, which is the equation of motion for a system of particles. Okay? And in a future video, I will go into this in a little bit more detail. We need to understand, let me just zoom out again. We need to understand the difference between external and internal forces. Okay? We need to understand what is a system. Okay, and how do we set up our system? But I will look at that in a future video. All right. So what does a problem look like with a system of particles? Here is an example. Okay, example 13.3. Here we've got a system of particles. Particle 1, particle 2, particle 3, and they are interacting with each other. And we will see this in more detail in a future video. Okay, so hopefully this is helping, and we'll see you in the next one.